This question deals with the equilibrium of forces. We have a kite that we know is in equilibrium because we are told that it is hovering above the ground. So what we can do is we can apply the information that the problem gives us about the forces in order to determine the geometry of the situation. Here I have a free body diagram showing the forces that are acting on our kite. We have the force of the wind, which acts up at an angle of 63 degrees. And so we will put in a line here so we can draw the angle effectively. And we know this is 63 degrees over here. And then we know that the magnitude of that force is 20 newtons. So we'll write 20 newtons over here. So remember that. We don't know the weight of the kite, but it turns out it doesn't matter here. And we also know that the tension of the string that is pulling on the kite down and to the left here, as I've drawn it, is 13 newtons. But we don't know that angle. I'm just going to give it a name. I'm going to call it theta for now. And so what we can do is we can say that because this kite is not moving, it's just hovering, we know that the forces acting on it in any direction must add up to 0. So therefore, we can say the forces acting on it in the horizontal direction must add up to 0. So we can say the sum of the forces in the x direction equals 0. Now, what forces are there in the x direction? Well, there are two. There is the horizontal component of this 20 Newton force, which goes out to about here, that component of that one. And there is the horizontal component of the 13 Newton force going the other way, which goes out to about here. So what we can say is that 20 newtons times the cosine of 63 degrees acting to the right minus 13 newtons times the cosine of our unknown angle must add up to 0. So therefore, that gives us 20 times the cosine of 63 is equal to 13 times the cosine of theta. And therefore, that's going to give us that 20 times the cosine of 63 over 13 equals the cosine of theta. Now, we can use then that information to figure out what theta is. Something like this. If you do that math on the left-hand side of that, you get 0.698447. And that is equal to the cosine of theta. So then taking the inverse cosine of 0.698447 gives us that theta must be this angle here. So next, we can figure out the height from that information. We know that angle, this angle in here, is 45.697 degrees. And we know that the length of this rope over here is 49 meters, the string, I should say. And so we can just use trigonometry to figure out what that height is then. That height, the opposite side divided by the hypotenuse, must be equal to the sine of 45.697 degrees. Therefore, the height is 49 times the sine of 45.697 degrees. And that comes out to be H is equal to, we get 35.067, but we can round that off to just 35 meters because we only have two significant digits in the numbers given on our problem. And that is our answer. And it is a reasonable answer when we look at that this is 49 and this should be less than that. And things seem to have worked out. So there you go.